It's a series resonant inverter with unidirectional switches. This is the circuit diagram with two switching devices T1 and T2 as the thyristors, and L and C is the resonating circuit. This is very simple series resonant inverter. At initial position, the current I0 through the load is 0, remember this, and the voltage across the capacitor is minus Vc as shown in the polarities. Now, when thyristor T1 is turned on by giving a pulse, the current tries to flow through the thyristor T1, inductor L, and capacitor C through the load back to source from the source. So, when the current starts flowing, the capacitor Vc is reversing and becomes 0, and then starts increasing in reverse direction and reaches a value of Vs plus Vc. And the current which is flowing through the load starts increasing and reaches the maximum value when the voltage through the capacitor is 0. Then, as the voltage increases to maximum value of Vs plus Vc, the current is going to decrease and becomes 0. This is the time period T1. When the current through the load becomes 0, the thyristor comes to self-commutation and stops conducting. This is the equivalent circuit for mode 1 operation. We should not turn on T1 and T2 at the same time. If both are in operation, they are going to short circuit. So, we are going to turn on the thyristor 2 after some delay TQ. Meanwhile, there is no change in the current. There is no change in the voltage of capacitor. When both are off, in this period TQ, the capacitor is reversed to a new value of Vc1 and polarities also changed to positive. This is a capacitor and the load, where the flowing current I0 through the load is 0. This is a mode 2 when both the thyristors are turned off. Now, when you turn on the thyristor T2 by giving a pulse, the time T by 2 or at the half of the time of the cycle, a reverse resonant current flows through the load. The current flowing during the first mode of operation is I1, second mode of operation is I2, third mode of operation is I3. Now, here the voltage is Vc1, which equals to Vc2, let it be positive and negative. Vc1 and Vc2 both are equal. Now, during this term, the reverse current tries to flow as the capacitor starts discharging. When T2 is on, the reverse resonant current starts flowing as the capacitor, now it is charged to Vc1, that is a maximum value. Now it wants to discharge so that the current flows in the reverse direction through the load. Here I have shown that through the load. Now the reverse current starts flowing and reaches a maximum value. In the meanwhile, the capacitor starts to discharging and reaches a 0 value. Then it discharges and becomes negative Vc. The current reaches the value of 0, I0. Then, when the current flowing through this circuit reaches 0, the thyristor T2 comes to self-commutation and stops conducting. Here also we have the time TQ until the next cycle T1 is turned on. And this process continues in every cycle. So, from here to here, we have considered that as a mode 1 T1, and here to here we consider that as mode 2 when no thyristor is on, and here the thyristor 2 is turned on. Let us consider this as the mode 3, so T3. This is how the actually series resonant inverter with unidirectional switches operates. These are the equivalent circuits, and this is our waveform, and this is the circuit for series resonant inverter. If this video is useful, please like, share and subscribe.